Now remember, in this chapter, we are talking about the difference between two proportions, at least in this first section. So they take two simple random samples of teens, 800 in the first sample, and 400 young adults. They must be a little older, and they get these two proportions, 79% and 67%. Now, let's see, what are the appropriate hypotheses? Let me write that down. So the null hypothesis is, remember I always say this, no difference. So in other words, we might expect that the population proportion between these two groups, if we subtracted them, would be 0. No difference. Meaning they would be the same, and if you subtract them, you get 0. And then the alternative hypothesis is we just want to know if there is a difference. That means that if we subtract these two proportions, we're going to get a number that is not 0. That's it. So there we are with our hypotheses. And then what are the parameters? Now don't forget that parameter is with population. Parameter, population. So the parameter is we're looking at the true proportion for the entire population of teens that use or own an iPod. And the true population proportion, okay, this is what our estimate is, okay, we're trying to figure out for the population. We have an estimate, and that is our sample proportion. But anyway, there we go. So the parameter is the true proportion of teens that own an iPod and the true proportion of young adults that own an iPod. There you go. Okay, let's go to the next question. So on this one, we want to carry out a significant test at a 0.05 level. So what we are doing is we're trying to figure out the true difference between the proportion of the population of teens that own an iPod and the proportion of young adults that own an iPod, and the difference between those two. And like we did before, I'm not going to go through all this stuff. So this was on number 15. So we know that the null hypothesis is we want to subtract them and see if it's 0 versus it's something different. And then don't forget, we're going to do random, normal, independent. And we did that during class, so you can kind of think about what that would entail to write that up. And then, let's see, we are going to do a 2-proportion z-test. So there's that. And what I'm going to do is I'm going to just focus on the do part. So we're going to come up with like a z-score. And what do we think? Well, we think that our null hypothesis is going to be 0. That's what we expect we should get if the null hypothesis were true, versus our two proportions, which is 0.79 minus 0.67. Okay, so that's how you set up the top. Then we need the standard deviation. So this could be a little bit tricky. So we're going to do 79 out of 800 students. So how many was that? So we just multiply. And we get 632. 632. And then 0.67 out of 400 students. Yes. Let's see what that number is. And that number is 268. So let me write this down. 268. Now why is that important? Well, we are going to combine these two to get a more accurate representation of the proportion of the entire population. So we add these two numbers together. This number and this number. And that is 900. 900 out of a total of, what was it? 1200. Okay. And that number is going to be 75%. So what we're going to get is 0.775. And that's what we use for our population proportion. So we're going to say 0.75 times 0.25 over our first sample size plus 0.75 times 0.25 over our second sample size. So that is our standard deviation. Okay, so now you got to crank out this number for this big, huge thing here. Like that. So after doing that, you get a z-score of, z is equal to 4.528. Okay. And we put that into normal CDF. So since it's 4.5 standard deviations above the middle, it's going to be pretty close to 0. So I put it into normal CDF and then did negative 1,000 to 4.52, subtract it from 1, and then don't forget that we're going to multiply it by 2 because we're doing that not equals 2 thing, and I get this number. It is a what? There's 5 zeros in front and a 618. Okay, what does that tell us? The p-value, the meaning of this is that if it was true that the difference between the two populations was 0, the fact that we would get a two samples that were like this, even though they're supposed to be the same, would only happen, what is that? Approximately 6 out of a million times. So we're going to reject the null hypothesis. That's the conclude part. Reject the null hypothesis in favor of saying, yes, we think that these two groups definitely are different. Now I just want to double check using the calculator. Remember, stat over to tests, and it's a 2 proportion z-test, number 6. And I put in these numbers. So it was 632 out of 800 students that were surveyed. That was the younger kids. And then 268, so this is x up to 268 out of 400. And the test is going to be that not equals to, and I'm going to calculate, and I get the same answer. It's 6.03 e to the negative 6, so that's like 5 zeros in front, just like I was saying before. Okay, using the calculator to check our answer. There we go. Now next we're going to do a confidence interval on the same problem. So, and we are going to do a 95% confidence interval. I like to just say CI, confidence interval. Okay. So for our confidence interval, we're going to subtract the 2 proportions, and then we need that z thingy, critical value is what they call it, a little asterisk there. So in inverse norm, you put it's 0.975, which gives you a value of 1.96. 1.96. And we have to do the standard deviation. Now, we don't pool the data this time. So for the standard deviation, we are going to get 0.79 times 0.21 divided by 800. And then the other one, which was, what, 0.67, 0.67, multiply that by 0.33, and we're going to divide that by 400. Okay, so there's the formula. It's P1 minus P2. We got to get this critical value, so that's that z-score. You can, if you're still confused as to how to get this number, I'll help you. Just ask me during class. And then here are our two proportions, 79 and then 1 minus 79 divided by the sample size, 67 minus 1, the other one, divided by that sample size. Do all this math here, add it to this, and then subtract it from that, and you get your confidence interval. But again, I am going to go into the calculator and have the calculator do it for me. So stat over to tests and way down letter B, which is a 2 proportion z interval. I'm going to put those numbers in. Now the thing that's kind of nice is that because I used the test before, the numbers are already in there. The calculator is going to assume that you're going to do a confidence interval as well. So I calculated it, and it goes from here to here. So here's our confidence interval. We are 95% confident that the true difference between these two proportions is somewhere between 6.5% and 17%. Is 0 contained within this confidence interval? And the answer is no, which gives us more evidence to say, well, we just don't think that it's possible that the two groups could be the same. In fact, we're 95% sure of it. Okay, that's number 17.